Hi, in this series of small videos, we are going to look at some very interesting physics ideas and physics problems which I encountered in my teaching career and in my teaching experience based on my own thought process and and based on whatever students have asked. So I'm going to look at a very interesting idea today. It's a very small problem. If you take the one-dimensional motion, 1D motion, I have here this idea that acceleration is dv by dt, which by chain rule I can write as dv by dx into dx by dt. And we know dx by dt is again the velocity, so v dv by dx. Generally, we use this in 1D motion. So now if I throw a ball and it is going up and again it comes back, this is exactly 1D motion. In fact, the motion here is happening along y-axis if I take this as y-axis. Or you can take this as x-axis also, no problem. You are taking vertical as x-axis, so motion is happening under x-axis. But let's take it as y-axis. Then I can write here a equal to v dv by dy here, because the motion is happening along y-axis. It's happening in a straight line. Though I show that this ball is going up and coming beside it, actually it's straight line. It's going up and coming back in the same path. Now, if I look at the highest point, the ball stops, so v is 0. So if I use this relation, I can use this relation at any point during the motion. So if I use it at highest point, then at highest point, this motion is happening under gravity g. So a happens to be minus g because I took positive y-axis up, and v is 0. So it looks like you are getting g as 0, which is absolutely insane. Something is fishy here. We know that g is roughly 9.8 meter per second square, or you sometimes take it as 10 meter per second square, but g is 0. How would you explain this? Where is the mistake? So if you pause the video and think for some time and see if you can get the answer, that would be good. Anyway, I would give the solution here. The point is, even though v is 0, the problem here is dv by dy. It shoots up to infinity. So I am getting minus g is something like 0 into infinity, which is kind of indeterminate. So the equation is still correct. So the equation a equal to v dv by dy is still fine, is still correct. There is no problem with that. So even though this v is 0 at highest point, this dv by dy tends to infinity, and the product of 0 and infinity could still be a good number like minus 9.8, or depending on the situation, whatever it is. Now immediately there could be a challenge. How do we prove that really dv by dy is 0? So I can prove it in one way, and it's like this. We start from the highest point, where let's start the motion from highest point where u is 0, and in the next delta seconds, which is a very small time, let's find the velocity v equal to u plus gt. If this delta is very small, I can write dv is g delta. V minus 0, I can write it as dv if it is a very small time. Final velocity minus initial velocity, I can write it as dv. And I know that the displacement y is half g delta square. I could write it as dy actually, is half g delta square if delta is a very small time. And if I do dv by dy, I have dv here with me. So let me underline this with a different color. So I have dv here and I have dy here. So dv by dy gives me g delta by half g delta square. So it is giving me 2 by delta and as delta tends to 0, this shoots up to infinity. So you see dv by dy is tending to infinity at that moment when the particle is at the highest point. So that is the explanation. So I hope you liked this video, and we'll be doing many such videos during the coming days. Hopefully you will like it. Thank you.